Right, are we live? Quick shout out in the chat room. Are we live? Testing, testing. Is the audio good? Music alright? Everyone cozy, comfortable at home and doing, just chilling? All that good stuff? Is the stream online? I hope the stream is on. Alright. Alright, give a shout out in the chat if all is well. And if all is well, then welcome everyone to the pre-calculus midterm test. Yes, we're going to do a past year midterm test for in the school where I'm teaching. This is the first installment of a 3-part series in engineering mathematics. So these questions can get rather go from very straightforward and very simple, and it progresses in difficulty as we get along. So let's start off with the first question, which is to solve, let's write it this way, solve the exponential equation 3 to the 5x minus 2, equals to 81. Alright, so the first task is to solve this particular equation, and the approach in which we are going to take to solve this equation is to undo exponentiation. Hey, long time no see, it's been a while. So what we'll do is, we will take the natural logarithm on both sides. And the idea here is that the logarithm is able to bring down the power on the top, like this. Now, what's even more interesting is because we know that 81 can be written as, well, that's 3 to the power of 4. Another way of thinking of that is, well, 81 is 9 squared, which is 3 squared all squared, which is essentially 3 to the 4. And once you have that, taking the logarithm on both sides, we can bring the power down, just like in the previous case. And the idea is that once we bring the power down, well, then we just simply get 4 times the logarithm of 3. Now with 4 times the logarithm of 3, we can now do a little bit of cancellations that give us a relatively straightforward equation to solve. So that gives us 5x, let's write that more neatly. 5x equals to 4 plus 2, so that simply simplifies to 6. And finally, x can be written as 6 divided by 5. So that is a relatively straightforward warm-up question, which leads us into the next question of the midterm test. So the next question is yet another equation solving question. Essentially, this course is all about solving equations. In a sense, we only find these tools useful if they help us solve equations. Right? Yes, my background might be in pure mathematics, but when it comes to practical uses, we are more interested in solving equations than any kind of theoretical interest. Is this paper similar to the O-level A-Math? It's somewhat similar, right? The content, there's quite a significant amount of overlap in the two. Of course, things get a little bit more tricky in the second half of the course. So what we're gonna do to solve this equation is to do a bit of cross multiplication. And of course, if you like some details as to how that works, please leave a comment in the chat. From this step, we have a bunch of different products which we can expand using what we like to call the rainbow method. Some of you use the tabular method, Honestly, whatever method works. In mathematics, we call this the distributivity of multiplication over addition. The first two terms is 3x multiplied by x, so that gives us 3x squared. The second term here is 3x multiplied by 1, so that's just simply 3x. On the right side, we have 2 multiplied by x, so that's just 2x. And we have 2 multiplied by 1, so that's just simply 2. Now we can bring all of the terms over to the left-hand side. Well, that's minus 3x minus 2x, that's minus 5x. Whoops, I'm gonna bring a 2 over as well. And this equation looks a lot like a quadratic equation. Now, of course, if you have a calculator to solve this equation, go ahead. I don't have a calculator. Well, I kind of do, but for the benefit of those without calculator, we're going to use the quadratic formula. That would be negative of b plus or minus the square root of b squared minus 4a times c. And in this context, a is 3, c is negative 2. This is b, and this is a. And of course, the last thing is that this is a c. So we're going to take that divided by 2 multiplied by a. Now let's do a quick simplification of the problem. That will give us negative of 5, that is just the positive of 5. Negative of 5 all squared, that's 25. 3 times minus 2, that's minus 6. Minus 6 times 4, that's, the whole thing here is minus 24. So we're taking 25 minus the negative of 24, which simplifies to 49 because the double negatives turn into a positive. So we're taking 5 plus or minus the square root of 49 all over 6. And 49 is a really nice number. It is the square of 7, right? Here, of course, 49 equals to 7 squared. This gives us two solutions. 5 minus 7 over 6, or 5 plus 7 over 6. And that would simplify to negative of 2 over 6, so that's 1 over 3. Or 12 over 6, that's 2. And of course, you can check that these answers over here do not violate the zero denominator conditions over here. So we are good to go. So the answer over here is that x equals to negative of a half or 2. I think it's not negative of a half. I think it's negative of a third. Whoops. Kind of made a typo error over there. Oops, let me clean this up. Let me try to find a more stable position for my iPad. Alright. But hopefully that's how it works. And both solutions work out in this context. So if you are curious where we're getting the questions from, the questions are in the document in the description box below. So you can check that out and attempt these questions for yourself before looking at the video for the solutions. For the next question, we're now going to solve a logarithmic equation. So there is a clear emphasis on equation solving. Right, we're taking the logarithm of x equals the logarithm of 7 plus 1/3 the logarithm of 27. And the key idea here is that, well, to deal with logarithms, we are gonna try to apply the reverse of logarithms, which is taking exponentials. Here, when we use LOG, the convention is that log refers to log base 10. Of course, ln by convention refers to log base e. So just some notation to keep in mind in this discussion. On the left side, the 10 and the logarithms cancel out, so we are just simply left with x. On the right side, the exponential satisfies a very nice property. It is able to split up addition and convert it into multiplication. Oops. And if you are curious for the proof as to why this is the case, you can check out one of my videos, which I'm going to link in the description box somewhere, somehow. So the first term is going to have the cancellation effect once again. So it just simply refers to 7. For the second term over here, we might want to do a bit of simplifications before we write out the answer. So 10 to the 1/3 of the logarithm of 27. Well, the logarithm has this property where it's able to either pull down powers or push powers back up. So we can push this power back up. And what we are left with is 10 to the logarithm of 27 to the 1/3. Once we have that nice property, the 10 and the logarithms cancel out once again, and we are left with 27 to the power of 1/3. But 27 is very conveniently 3 cubed all to the power, well, that's 27, and we're taking this number to the 1/3 power. In a sense, the 3 and the 1/3 cancel out as well. We are left, therefore, with 7 multiplied by the number 3. And that simplifies relatively straightforwardly to 21. So here we are using a bunch of interesting properties that exponentials and logarithms satisfy. Of course, we have the property that the exponential converts addition into multiplication, and we're using the fact that logarithms can either bring down powers or push them back up, and of course the fact that exponentials and logarithms cancel each other out. So these are the 3 tools that we are using in order to solve this logarithmic equation. Alright, so far things are pretty straightforward. Of course, things get a little bit more hairy later on. We're now given this question, given these two functions. So for the next question, we are given two functions, f of x and g of x. And we need to evaluate two different expressions, f of g of x and g of f of x. And in general, these two expressions look very different from each other. It's a really important warning, just in general, to not mix up the calculations. So let's go ahead to do this evaluation. We're going to take gx and plug it all into the f of x. So I'm going to take g of x and replace all instances of x over here with g of x. So it's going to look a bit like g of x all squared plus 2 times of g of x minus 5. So that would simplify to x plus 1 all squared plus 2 times of x plus 1 minus 5. And finally, we can do a bit of algebraic expansion for the first term, and a bit of algebraic expansion on the second term. Finally, simplifying that. So the answer is going to be x squared plus 4x minus 2. Right over there. We can do a similar calculation for g of f of x, which I'm going to perhaps try to make space to do it. Alright, let's just I'm going to try this out, like that. Let's see if this works. I think this should work. So now, instead of plugging g of x into f of x, I'm going to replace all instances of x with f of x. So this is going to simplify to f of x plus 1. Well, that's just x squared plus 2x minus 5 plus 1. And the 5 and the 1s will interact. Minus 5 plus 1 is minus 4. Rather interestingly, these numbers have a similarity to them, but unfortunately I don't think there's any mathematical, rigorously useful idea behind it. It just coincidentally looks the same. Alright, and for our final question in part A, we are given a trigonometric equation. In fact, this next question requires us to solve the trigonometric equation, cos of theta equals to negative 3 over 4, where 0 is between theta and 2 pi. So I've taught a bunch of different ways to solve this equation, but I found a rather sneaky cheat code that gets to the final answer very quickly. Okay, so here's my cheat code. Firstly, we calculate the basic angle. That's the inverse cosine of 3 over 4. You could even use a calculator to help you do that. I will do that right now. So let me just do that. Cosine, the inverse cosine of 3 over 4, right, is, well, give me a moment. We want to express this in radians, so we're going to write this as 0.72273. Now, here's my little sneaky shortcut in all of this. You could draw a graph if you wish, but one thing I know is that as far as this range of values is concerned, theta can only take one, or rather two, of four possible values. Theta, pi minus theta, alpha, pi minus alpha, pi plus alpha, or 2 pi minus alpha. Now, if I were to type these things into the calculator, I'm going to observe that this quantity, well, the cosine of this quantity, or maybe I should think of it this way, the cosine of this quantity, if I type into my calculator, is going to be the positive of 3/4. The cosine of this guy, according to our calculator, is the negative of 3/4. Likewise for this guy, and likewise for the last term. So in other words, we want to solve the equation cosine of theta equals to minus 3/4. It turns out that only these answers over here, or rather these angles, pi minus alpha and pi plus alpha, give us minus 3/4, which means we can eliminate these other options over here. We can eliminate these options. So what does that look like in practice? Essentially, I can strike out these two options. And I'm left with these two options, pi minus alpha and pi plus alpha. So let's calculate pi minus alpha. That will give us, that will give us 2.41886. And what's pi plus alpha? That will be 3.86432. In our convention, as far as our school is concerned, we're gonna use 3 decimal places as our final answer. But of course, you can check with your respective precisions. Alright, now those questions took some time, although in practice we should be a lot quicker to solve those questions. Alright, so that's for part A, that's the questions for part A. And now we're going to look at the questions for part B. Well, it's not really a solve question. We are given a graph that looks a bit like this. And of course, the graph is given in the paper itself, but of course, for the purposes of YouTube, I'm going to draw out that graph manually. So what we have here, it starts at the point -2, 1. It goes down to -1, like this. And then it will go up to 3, 2, like this. It will go down to 5, -2. This is a really wonky graph here. There we go. And finally, it ends off at 6 -2. So that's the graph that we're given. Perhaps let me indicate that using a different color. And the question asks for what is the domain of this function? So this is the function y equals to f of x. And what is the range? Well, the domain is the set of possible inputs, aka the x values. So we are looking at this collection. These are some of the possible inputs from -2 to 6, and we are going to take everything in between them since these are the possible inputs for this function. So our domain is going to be, in fact, you could write this in compact set notation, you don't have to. X will be in between -2 and 6. And according to our graph, we will include -2. So we include that. And we will include positive 6 as well. Like these 2 points are included in our graph. So we're going to include that. Now, what about our range? What is the range? Well, the range is the plausible outputs of the function. All the different possible outputs you could possibly get from the function. So in this case, the function sort of starts from 1, it goes down, it goes up, and then it goes down, and then it kind of remains the same. In other words, if you were to look at the corresponding values on the y-axis, you're going to get all the numbers between -2 and 2. And of course, this point is included, therefore 2 is included. This point is included, therefore -2 is included as well. So that's the domain, and that's the range. However, that's sort of one of the questions, but then we are given a second question which basically asks, what are the values of y when x lies in between 4 and 6? So we have to think a little bit about that. Well, we are told according to the graph, and of course it's not so easy for me to draw it, but if you were to look at the graph given in the document, it actually passes the point 4, 1. So in other words, we are asking the question, given that x can take on any of these values, and we are going to exclude 4 in this case, right? We're going to include 6 in this case. What are the possible y values that we can take? Well, we definitely want to include all of these possible y values at least. In other words, we definitely want to at least include -2 and 1 and everything in between them. That's the minimal. Of course, that raises the question, should we include -2? Should we exclude -2? Well, the 0.5 lies inside the domain, so we do actually hit the number -2. So therefore, we are going to include that into our possible values of y. However, if we go up here, we don't actually hit the number 1 because 4 is not a valid input. So we actually cannot include 1 as our answer. Right? If we include 1, then we are trying, we need to include 4. But we're not including 4, so therefore we're not going to include 1. So it's a little tricky, but it's not as intense as it presents itself to be. Okay. Okay. So that's one of those questions, and there is another part to this question, and we are required to draw the graph of a slightly modified function. So this is y equals to f of x, but we need to try to draw the function, right? So we need to sketch the function y equals to g of x, which is given by f of x plus 2. So what does that look like? Well, essentially, we're going to take the entire graph and translate it up by 2 units. So I believe there is no need to, you can use the grids to help you identify the relevant points. Unfortunately, I kind of need to refer to my own drawing for this. So I'm going to have to take -1, right? -1 gets shifted up to +1 because we're adding 2 units. We're adding 2 units over here. So the new graph will pass through this point. Instead of -2, 1, we're going to get the point -2, 3. Instead of 3, 2, we're going to get the point 3, 4. Instead of 4, 1, we're going to get the point 4, 3. Try that out. 4, 3, yes. Instead of 5, -2, we're going to get 5, 0. And of course, instead of 6, -2, we're going to get 6, 0. So this is our graph, and we're going to basically follow the same shape as the original graph. So it looks a bit like this. There we go. This is the sketch of our modified graph. And finally, we are asked to find the maximum output of G as well as the X that allows for this maximum output. Well, I think from the picture, well, this is G of X, it looks like this, and the maximum output is right over here. It's going to be 2, but we're going to shift it up by 2 units. That's what G of X is all about. So it's 2 plus 2. Our answer is 4. The X value that gives it is still 3. Right? Essentially, we took the y equals to f of x function and we shift everything up by 2 units, which means that we didn't do any left or right shifting, which means we are safe. Alright, so that's the question pertaining a slightly strange graph and involving domains and ranges. On the topic of graphs, we're going to look at some trigonometric graphs as well. So the next question involves this particular function, y equals to 10 times the sine of 2t plus pi over 4. And we are asked to find a bunch of things. What is the amplitude, the period, and of course the phase shift. To solve this question, surprisingly, the technique is relatively straightforward, right? What I like to do is to factor the two. So on the inside, we're left with just, t plus pi over 8. This actually gives me all the information I need. Because the amplitude is given by this number on the outside. It tells you how stretchy, stretchy your sine graph gets. It gets stretched by a factor of 10. The period is given by this number in the sense that this number tells you the number of complete cycles in a period in a time of 2 pi. So since 2 cycles is completed in 2 pi amounts of time, then 1 cycle is completed in pi amounts of time. You can think of this as 2 pi divided by 2. So this is in fact the period of this graph. And finally, this rather isolated number here gives us the phase shift. Now, why does it give us the phase shift? That's where we're going to actually sketch this graph. In fact, we're going to sketch just 1 cycle of this graph. And here's how we can do this in a very systematic way. We can start off by, drawing our axes as we normally do. And usually we involve a t over here. What we do now is we consider the phase shift. The phase shift actually tells us where is our starting point. Now, since the phase shift is positive of pi over 8, we need to compensate for that by starting at negative pi over 8. We start there, and what we do is complete 1 cycle. How long is 1 cycle of a sine wave? Well, that's just simply the period. So we need to complete our cycle by taking minus pi over 8 plus pi. Right? That's 7 pi over 8. The idea is that this over here should have a time interval of pi. So once you have that, this is how I like to draw my trigonometric graphs. I like to draw a bunch of bounds in this manner. Let me draw it more cleanly like this. Whoops. I like to chop it up into 4 equal partitions. And then, since this is a sine graph, we will pass through these points, connect them. And since our amplitude is 10, we should label the bounds by 10 and minus 10 respectively. Right, so that's the start and the end. And we also have the amplitudes of the sine graph. Oops, kind of exceeded that. Over there. Now we are given a weird question involving some amusement parks are things I enjoy going to. Yes, even though I'm a working adult, but I like to think of using adult money to do some things that I couldn't do as a kid. And what we're gonna do now is essentially solve an equation. Now the youth screams each time the height reaches 23 meters. And we're told that the height is given, the question tells us that the height is given by 15 plus 10 times sine, of 2t plus pi over 4. we want to find the time in which the youth screams, that means we need to solve the equation. The youth screams whenever the height is 23. So we need to solve this equation. Oops. How does that look like for us? Well, we take h of t equals to 23. We can subtract 15 on both sides and then divide by 10 on both sides. This gives us the relatively more straightforward equation. Sine of 2t plus pi over 4 equals to 8 over 10, so that's 4 over 5. Interestingly enough, this is a part of a very nice right triangle, but let's not go nerdy here. We essentially need to solve a trigonometric equation, but we are asked for the first time in which it happens. So the idea here is that, well, we want t to be positive and be the smallest possible time. So what we have here is that since t is positive, then 2t has to be positive, and 2t plus pi over 4 must be at least pi over 4. This will inform the solutions that we can accept in our final answer. So we need to solve a trigonometric equation, and the process is surprisingly straightforward because we need to first find the basic angle. And using our calculator, let me just do that relatively quickly. Yeah, my graphing calculator is GeoGebra. You guys can use the scientific calculator, but I'm using GeoGebra to help me over here. So what we have here is a slightly different expression. We have 0.92730, and so our solutions are going to be 2t plus pi over 4 equals to, well, it could be alpha, or pi minus alpha, or pi plus alpha, or 2 pi minus alpha. Using the calculators, we can actually eliminate these options, because when you type it all into a calculator, the sign of alpha will give you a positive number. This will be positive, this will be negative, this will be negative. But we want the result to be positive. And what's even more interesting is that we could take these two options, and there are actually infinitely many options. We can just keep adding 2 pi to get all of our solutions. But we already know that alpha is 0.92730. If we check it out in our calculator, already is bigger than pi over 4. What that means is that we actually found our answer. We don't have to do any more work. This is in fact our answer, and all that remains is to solve for t. So this, well, lets me do a bit of algebra. Bring the pi over 4 to the other side, divide by 2, divide by 2 on both sides. So t equals to alpha over 2 minus pi over 8. Unfortunately, I need my calculator to calculate this, so there'll be 0.9273 over 2 minus pi over 8. The answer over here is going to be 0.07095, which is a rather short amount of time before the youth starts screaming. I guess the 10 really does play a role, right? Because this 10 here causes the graph to change at a relatively fast pace. So that is in fact how we deal with the trigonometric equation. Finally, we are left with the hardest set of questions which take up the most amount of effort. So the first part of this, of the more challenging questions, is to solve this equation, which looks a little bit annoying, but with some thought we can see that 9 can be written as 3 squared. And you might be wondering, why would we want to write it in that manner? Well, if we've practiced our papers and our tutorials, there are, well, this really is a standard technique that we've seen many times. But the idea is that 3 to the x is going to play a special role for us in this question. So the idea that we're going to do right over here is that we're going to write this as 3 to the 2x plus 2, right? Because we can do the multiplication. We are using this property over here. And then we can split up the exponentials, because exponentials have this very unique property that you can convert addition into multiplication. I believe I'm in error. This should be 2x, not just that. So what that looks like for us over here is that, well, this 3 to the 2, well, that simplifies to 9. Very nice. And 3 to the 2x simplifies to 3 to the x all squared. The reason for that is because if we now let u equals to 3 to the x, this equation can simplify to 9 times u squared plus u minus 5 equals to 0. Which looks just like a quadratic equation which we can solve. So let's solve the quadratic equation, and I believe I want to try to solve this without using any kind of without any kind of quadratic equations, but I don't think I can. 4ac is no, I don't think you can solve this without any quadratic equations. So you have to solve this using the quadratic equation. B squared minus 4ac all over 2a. This would simplify to minus 1 plus or minus the square root of 181, which is not a nice number in any way. But what we do know is that exponentials are always positive. No matter how you do it, exponentials are always positive. So what that means is that we can conclude that u being, well, u equals to 3 to the x has to be the positive solution, because 3 to the x cannot be a negative number. And finally, to solve for x, we can take logarithms on both sides. We can bring down the powers, just like the very early questions that we have seen. And we can divide the ln 3 on both sides. I don't actually know what this number is, so feel free to calculate that if you can. Right, that is actually going to be our final answer, which, yeah, it looks a bit strange and long and tiring, and of course there are a bunch of decimals to it, but that is pretty much our answer. I believe you can use your calculator to check it out. I don't have a calculator with me to do that, so the moment we've all been waiting for. Let's solve the hardest question in this test. Let's solve this hardest question. We need to solve, we're given f of x equals to e to the x minus 1 over 1 plus 2x. And we need to solve this particular equation. F inverse equals to log of x squared. And of course, log here is by convention referring to base 10, the logarithm base 10. Now, what that looks like for us is, takes a bit of effort, but what that looks like for us is that, okay, how do we go about this? Well, what cancels out the inverse? Well, exponentials, well, not inverse, well, if we start off with a function, or if we start off with an equation, what cancels out the f inverse? Well, that's going to be taking the original function. Cancellations happen. All that remains is to calculate some stuff which looks really horrible on the right hand side. Well, we're going to get e to the power of the logarithm of x squared. This is probably really the hardest question here. So it looks a bit like this. Now, what on earth did I do there? That was really fast, right? Well, essentially, here's the idea. When I write the symbol f of all of that, what I'm really saying is whenever I see an x, I'm going to replace it with log of x all squared. And so that's basically what we're doing here. We're replacing all the x's with log of x all squared. Like this. Right, we're basically doing that. In fact, I probably need to put this over here. Right, we're replacing all of the x's with logarithm of x squared. Essentially, f of anything is going to be e to the power of anything minus 1 over 1 plus 2 times anything, whatever this anything might look like. So what that means is we have a very complicated equation to solve. I do not like the looks of this, but I have an idea on how to go about this. I do have an idea. The idea here is to take the logarithm on both sides, which looks a bit strange, but trust me, it's gonna work out. Okay, trust me, it's gonna work out. Now, why is that gonna be useful? Well, because logarithms can pull out powers. Logarithms pull out powers. And so we can pull out this huge power. All of this can be pulled out. And we can multiply that by the logarithm of e. Of course, this is technically involving, you could do a bunch of change of bases, but we can leave it as that. I believe we can, that should suffice for now. And I think I know how to solve this equation. It takes a bit of effort, but we can do it. Now, there's a bunch of log x's floating around, so I want to replace all of that with the letter, say, u. I want to replace that with the u over here. So let's clean up some of the mess we see on the screen here. Every time we see a log x, we can replace these guys with the letter u. This time I want you. Okay, let's not go there. Looks a bit like this, right? we could still do some cross multiplications. A bit like this. Whoops, let's try that. So let's multiply this denominator up. This gives us u plus 2u cubed. On the right side we get u squared minus 1 times the logarithm of e. Now the logarithm of e looks weird, but that's just basically a number. So we can just expand that in. Look a bit like this. And then we can bring all of these terms from the right side. We can bring it over to the left side. And this looks like 2u cubed minus log of e, u squared, plus u plus the log of e equals to 0. Now this looks really complicated, but this is fundamentally a cubic equation. Because we're getting a constant multiplied by u cubed, another constant multiplied by u squared, another constant that's just 1 multiplied by u, and one last constant to wrap it all up. So we can just solve this as if we were solving a cubic equation. Now I'm going to try to solve this using my calculator. So I can do that. I think I can solve it, but I'm going to need to be careful how I do it. I hope the logarithms here on my calculator are the correct logarithms. Whoops. Okay, I do get a solution. In fact, using calculators, because we are allowed to use calculators, you have the solution u equals to negative of 0.322226. And okay, I think we're safe. This equals, well, what's u again? Well, u is the logarithm of x. Well, how do we obtain x from the logarithm of x? We apply 10 to the power of that on both sides. So x equals to 10 to the power of that, which is going to involve a bunch of decimals. I can already feel it. Oh, it's not too bad, surprisingly. So x is going to be 10 to the minus 0.32226, which equals 0.47615, which, whoops, clean that up, which equals 476. So that question took a bit of effort because we started with a very, very nasty expression. We started with two very nasty expressions. We observe that the inverse of a function and the original function will cancel each other out. So that's nice, but that gives us x and a bunch of other things here. The key trick is to bring all of this out by taking logarithms. Once you do that, you will notice that there's a bunch of log x's floating around, and that's where you can employ the substitution u equals to the logarithm of x. And then you can simplify, and while this looks a bit strange, this really is just a constant. Right? So let me just check one more time that I calculated this accurately. I don't think I calculated this accurately. This could be problematic. I think I didn't calculate my answer correctly. Whoops, I'm gonna have to recalculate a bunch of things. Oh. What? 1 Oh, okay. Whew. Oh, okay. Looks like we're all good. For a moment I thought I was doing a wrong calculation there. Alright, yeah, so once you make the observation that log e is just a number, then you can treat it like a number and plug it all into your calculator. You can solve for u, which gets us this expression, but u equals the log of x. So we can substitute that, and taking 10 to the power of logarithms cancels each other out. And then we're left with this example, this answer. Now, for the math nerds out there who want an exact solution, it's going to take some effort, but I believe if you try to use what we call Cardano's, or is it Bombelli? I don't know, one of them. Tartaglia. I don't know, but it's commonly referred to in the modern day as Cardano's method to solve cubics. You can use that method to obtain an exact solution. But since the class that I'm teaching is an engineering course, we're fine with approximations. Approximations work out well, right? Because of course, as we all know, the fundamental theorem of engineering is that pi equals 3 equals to e. So this works out for engineers. I asked my engineer friends and even my engineer brother, and they all concur with this sentiment. Anywho, approximations are fine. And this is our final answer to this complicated equation. X is approximately 0.476. Alright, so that's it for now. Alright, I think that's all that we have for today's stream. Right? Yeah, okay, I think this should be fine. I hope I didn't butcher anything though. Oh, wait a minute. I think I might have made a careless error over here because let me just check something for a moment. Alright. Okay. Oh, darn it. Okay. I think this is fine. Yes, this calculation is fine. Yeah, we're good. I was just concerned because my calculator, I do not know what's the notation, but I think this should be the correct answer. If I did not get the correct answer, it's probably because I used the wrong calculator. So I'll probably need to edit my answers from here on out. Alright, so that's how you deal with this question. It's a slightly long question, but it gets the job done. So that's that. Alright, so that is it for this discussion of the poly math test. This is the midterm test last year for engineering mathematics, the first iteration. I'll be doing one on Friday, which is the third iteration. There'll be engineering math 3 that involves differential equations and Laplace transforms. Fun stuff, but you can see that the last question takes a bit more effort. So it does take a bit more time. Fair enough. So that is it for this stream. And I will catch you guys when I catch you guys. Hopefully I can see you guys in the next one. With enough practice, you'll be fine. We do have a few term tests for practice, so that should be fine. You might want to check out your plus or minus symbols as well. That will greatly affect the answer.